Hello everyone and welcome to DhiNexus. I am Oorja Chandravanshi and today we'll be learning about preparation of alkyl. At DhiNexus, we try to make learning simple, engaging and clear. So stay tuned till the end of the session to understand about preparation of alkyl halides and many more upcoming topics. So what are alkyl halides? Let's begin with that. The general formula we all know is written with R and X. What is R in this? R is nothing but alkyl. This is halide. This another way to learn it. We call it haloalkane. And this is called as the IUPAC naming. This is the IUPAC naming, which is haloalkane, and alkyl halide is a common name. So, why are we studying about this group? Alkyl halides, haloalkanes, this is primarily useful for students studying organic chemistry. So, if you're a student preparing for IT, JEE, NEET exam, the basics are quite important. You must know how to prepare alkyl halides, and there are primarily three ways of preparing them, and then there are certain subheads. So we'll have a look at each of these in detail. This video is going to be useful for anybody who's preparing for IT, JEE, NEET exam, or if you're preparing for your school exam where you're studying about alkyl halides and their properties. So before beginning all that, you need to learn how to prepare alkyl halides. So first is we have alcohols. Second is hydrocarbons. Third is my halogen exchange. So if somebody can recall, alcohols are in general written as ROH. This is a general formula. What about hydrocarbons? What are hydrocarbons? We must know that hydrocarbons are categorized into three parts: alkanes, alkynes, and alkenes. Alkanes are generally those which have, not generally, these are the compounds which have single bond, carbon-carbon single bond. Alkenes have carbon-carbon double bond, and alkynes have carbon-carbon triple. Halogen exchange, in this, you basically have a look at the change of halogen. So basically, if you have RCl and RBr, these are going to change and give us RF and RL. Iodoalkanes are highly unstable, and same goes for fluoroalkenes. These are quite violent, so preparing them requires care. Hence, halogen exchange are prepared, used for preparation of fluoroalkenes as well as iodoalkenes. Let's have a quick look at each of these. So, in alcohols, if I just write one more thing, the subpart that we'll be seeing in alcohols is from first would be direct addition of or rather reaction with HX. Then we'll see with phosphorus halides, so PX5 and PX3. And third would be SOCl. So if you can guess, it would be primarily used for preparation of fluoroalkanes, alkanes and alkynes and alkenes. So alkanes here uses, I just distinguish all of these. So alkanes, if you know anything about free radical substitution reaction. This is what we see. So this is free radical halogenation. Where we are directly going to be adding X2. And it provides us a mixture of products, and hence it's not the most preferred method for preparation of alkyl halides. Then alkenes and alkynes both will be undergoing two same processes where we'll directly be adding X2 and another one will be adding HX, which is called as halo acid or hydrogen hydrogen. Hydrogen acid. And in halogen exchange, the two reactions would be Finkelstein and Swarts. The Finkelstein reaction is used for preparation of hydroalkane, and this is, surprise, surprise, but the fluoroalkane. Okay, let's begin with a description of each, starting with alcohols. So, like I already said, alcohols are generally represented as ROH. If you are reacting it with the first type, which was with HX, so ROH plus HX would give you, if you would like to complete it first, pause the video and please complete it to see what products that you're getting, are they right or not. So, what we get is Rx plus H2O. Right? This, if I start with, suppose, chloroalkane, will give me, and I am taking 1 degree alcohol, so CH3, CH2, OH plus HCl will give me CH3, CH2, and you'll get Cl here along with H2. Now, there's one thing to pay attention. 1 degree and 2 degree alcohols. So what would a 2 degree alcohol look like? This would have, this would be connected to a carbon, which is connected to other carbons. Right. So CH3, CH, and CH3. This is a 2 degree alcohol. Now, on reaction, we require anhydrous ZnCl2 in both the cases. We require anhydrous ZnCl2 along with HCl. We will be getting here Cl and H2. So this is called, both of these are called as Groove's process. What does anhydrous mean? Anhydrous means that there's no presence of water on it. So please remember, if I have not drawn hydrogen on any of the carbon atoms, that means it is a skeletal carbon, and you have to just, in organic chemistry, there would be a lot of cases where I might skip and not write hydrogen atoms. So you just have to complete the balance C of carbon in such a manner that it is full. So this is called Groove's process. And however, if I take 3 degree alcohol for preparation of tertiary alkyl chloride, it can just take at room temperature. So I'll get this. Now, what is the reason for it? Reason for high reactivity of alcohol is that it is in the intermediate state is a tertiary carbocation. But secondary and primary carbocation are not as stable as tertiary carbocation. So, tertiary carbocation, tertiary alcohol can just take place without the presence of anhydrous ZnCl2 and at room temperature. However, ZnCl2 in these two cases help in cleavage of the carbon and oxygen bond, and it is a Lewis acid. So it is really important to put that. If you're finding this video useful, then I would highly suggest you to like it and share it with your friends so that it's also helpful for them. And please do not forget to subscribe so that you can be updated about learning more themselves. Next, we'll have bromoalkenes. The reaction is pretty much the same. However, we can take concentrated H2SO4 this time as a catalyst and heat it. So what will I get? I will get this bromoethane along with H2. Sometimes we take KBr plus H2SO4 instead of directly taking HBr. The reason being HBr is a little reactive and hence we prepare it in situ. What does in situ mean? In situ means that I'm preparing it during the process and not like, I don't have HBr prepared already, but it will be prepared if I'm taking two other substances. So from KBr and H2SO4, I will get HBr. And this on heating will give me this product already. Hydroalkanes also work in the similar manner. With HI, I will do something called as a reflux on it. And what is reflux? Reflux is nothing but if you're just taking a beaker and covering it and heating it. So there would be a sort of condensation that will take place continuously. Such a process is called reflux. And I get H2O here and one more. This again an indirect procedure for preparing hydroalkane. So here I'll get. If my speed seems a little fast, I recommend you to pause the video and note down the reactions. So that was about preparation of alcohols from what? Haloacids. These were haloacids. That marks the completion of our first study. Moving on, we'll be seeing reactions with PX5 and PX3. Second in this would be phosphorus halides. So ROH plus PX5 gives me what? I get POX3 plus RX. This is of course my main product and what I require along with HX. And ROH plus PX3 gives me 3RX plus H3PO3. What is the name of this compound? It is called phosphorus acid. And this here is called as phosphorus oxychloride. Oxychloride if it is using chlorine. So phosphorus halide. Phosphorus oxyhalide. This I hope you were able to guess. This is again a hydrogen halo acid. Right? So let's look at some example. It's always important to learn the general equation as well so that we can form any example on our own as well. So let's take CH3CH2OH with PCl5. What will I get? I will get chloroethane along with POCl3 along with HCl. Right? This is one example. I want you to try for another for this one and see if you're getting it right. Now, again, my bromoalkanes and iodoalkanes via this method are a bit reactive. So what do? I again prepare them in C. How is that done? So for bromo, I'll just directly write it here. You have P4 plus 6Br2. So, Br. This compound can be unstable if prepared directly. So, if taken directly in the reaction, hence we prepare it like this. Okay. So, then suppose I'm taking 3 molecules of ethanol along with PBr3. You should be able to guess the product. It won't be anything other than. I want you to try the reaction with 6I2. What will you get? And also give an example of the same. I hope this part is clear, and that marks the completion of second type of with alcohols, that is PX5 and PX3. Third is very important, SOCl2. SOCl2 is highly used for preparation. So that exists SOCl2. This is also called as thionyl chloride. Now, why do we use this? As I was saying, alcohol with SOCl2 gives me RCl plus SO2 and I get HCl. These two byproducts are my gases. And such reaction is always preferred, which will give byproducts as gases so that my main product is easily attained. Please try an example of this on your own. R can be anything. You can take it to CH3, you can take it to CH, C2H5. It's not hard. When you try it, you will get the answer. So now we complete alcohols and moving to hydrocarbons. So hydrocarbons, first we'll start with alkenes. What is the general formula of alkenes? It is CnH2n plus 2. What is n here? N can be any integer number. So the first process and the only process that we'll be seeing in this is free radical substitution reaction of direct halogenation. I will take, suppose I'm taking propane and reacting it with Cl2 in light. What will I get? I will get two products. Now, what is the reason for getting chlorine here and this case here? As some of you may be able to tell that this will be a major product. For example, suppose this has 55% of presence and this has 45%. What is the reason for this? Look into something called as Markovnic order. Markovnikov rule will tell you. Let me spell it out. So Markovnikov rule always prefers that product which has less number of hydrogen. Where do we have the less number of hydrogen? The middle carbon has the least number of hydrogen, so major product will be that. I want you to try the example of CH4 plus Cl2 and see what you will get as the product. You can leave the answer in the comment section. Right. Next is reaction with alkenes. So alkenes, we must know that the general formula is CnH2n. And the smallest alkene is nothing but ethene, so CH2 and CH. If I reacted with HX, what do I get? I get CH2 and I get one hydrogen here and a halide. This is a type of reaction called addition reaction. So what is this? This was the first type, addition of hydrogen halides, addition of HX, right? An example, write an example here. Instead of X, I can take suppose HBr, and what will I get? CH2, H, CH2, and Br. Please try its IUPAC name, it's not very hard. And also try its common name, that would be good. And the second type is addition of halogens, directly addition of halogens. What are halogens, or like how do halogens exist in nature? If you're aware, halogens are in an elemental state existing as X2. Why? What is the reason for it? Why are halogens existing as X2? Please research about it a little bit. And if you know the answer, please leave it in the comment section. So this along with CCl4 is also going to give me an addition product. I will get 2x here and H. What is this compound called? This is called vicinal dihalide. Whenever you have halides adjacent to each other, you'll get something called as vicinal dihalide. Also write it in short as big dihalide. Try an example of it. Now, you must know that if you add CH2 with bromine under ethene with bromine and CCl4, bromine is actually reddish in color. It's red brown, reddish brown. Now this reddish brown actually leaves its color and gives a product which is going to be colorless in nature. So this product that we get here, it is colorless. This is used as a test for unsaturation of double bond. Basically test for unsaturation. It is used for both double bond as well as okay. So this is what we get here. There's an exception to this rule, allylic halogenation, where my allyl bond stays intact and suppose I'm taking propene and I'm taking a very high temperature. It's supposed to be like around 773. So where will the addition take place now? This will take place on this count. This is called an allylic halogenation and takes place at high temperature. Along with S. This is a propene. So my alkynes also react in the similar manner, like I also already said. We'll have a look at each of these. With alkynes, what do I get? First is my reaction here. HX. So addition of this is going to give a double bond here. And if I'm taking another molecule of HX, if that's going to land. Sorry. Will be here. So what is this now? This is called geminal halide. This is our geminal product. Geminal dihalide product. Since the addition of halogen took place on the same carbon. Now next is, I want you to try the example of it. Just in place of X, you can take either chlorine or bromine. I would recommend you not take iodine or fluorine because fluorines are not reactive in such cases and iodines are reversible. So an example, you will be trying for all of these. Next is addition of halogens, directly addition of halogens. So that will be the B part. With X2, what will I get? If you can guess, then you must write it in the comment box. So this is the kind of product that we attain. This is a tetrahalide. What about this one? This is a dihalide. Okay. This marks the completion of from hydrocarbons as well. So we've written a lot, learned a lot today. You should be proud of yourselves. So alkanes, alkenes, and alkynes. This is also covered. And lastly, we just have two reactions with Finkelstein and Swarts. Let's have a quick look at it. So Finkelstein reaction, it is, as I already said, for the preparation of what do we prepare from it? We prepare isoalkanes, so R. General reaction means Rx plus NAI with triacetone. It is going to give me Ri plus NaX. What can my X be here? X cannot be I, X cannot be F. It is only going to be chlorine or bromine, right? And another reaction is that of Swarts. So this is used for preparing chloroalkanes. I'm taking RF with, so here I can take a number of salts. I can take Hg2F2 or I can take SV, can also take AgF, COF3, and last but not the least, SBF3. All of these are going to give me equals Rx. Again, X can be either chlorine or bromine. So what will I get? Rf plus whatever salt. So let's take an example in this case. Suppose I take CCl plus Hg2. Do that gives me Hg2Cl2 and plus chloroethane. So that was the completion of preparation of alkyl halides. If you like this video, then please share it with your friends and do not forget to subscribe. Thank you. I hope you had a